Hello everyone, welcome to yet another video of wireless and AI. In this video, we discuss about a crucial layer of flexibility in 5G NR called as bandwidth parts. In the previous videos, we discussed about 5G NR resource grid and how does numerology affect the bandwidth of the resource grid and the component carriers, and also how the UE identifies the entire 5G NR resource grid and maps it to component carriers through a specific mechanism called as point A. In this video, we will be looking at bandwidth parts. If you have ever wondered how a 5G base station simultaneously serves a single tiny IoT sensor with say some 20 MHz bandwidth to a premium smartphone capable of handling up to 100 MHz, then this is the video for you. Bandwidth parts are one of the most elegant designs in 5G NR. Look at the diagram at the bottom of this slide. We have a single carrier with 100 MHz bandwidth. A premium smartphone gets the entire 100 MHz bandwidth. It can use all the resource blocks in this 100 MHz bandwidth. However, a mid-range UE can use only up to 60 MHz bandwidth, whereas an IoT sensor only gets 20 MHz bandwidth. All three devices are operating on the same 100 MHz carrier simultaneously, but each UE processes only the bandwidth part or the bandwidth that it can. So this is fundamentally different from 4G, where each UE had to deal with the entire carrier bandwidth. So bandwidth parts are how 5G deals with this elegant spectrum sharing across different device types. The formal definition of a bandwidth part is that it is a set of contiguous common resource blocks configured with a single numerology. It is a subset of the entire carrier bandwidth that is assigned to the UE. Thus, a bandwidth part is defined by three things: where it starts, that is the starting common resource block position; how wide it is, that is the number of resource blocks in that particular bandwidth part; and which subcarrier spacing it uses. A UE can have up to 4 bandwidth parts configured on the downlink and up to 4 bandwidth parts configured in the uplink. However, only one bandwidth part is active at a time. So the UE monitors PDCCH only within the bandwidth part that it is configured. It transmits PDACH, the downlink data is received only in the bandwidth part that is configured to the UE. The UE transmits uplink data only in the bandwidth part that is configured to it. So this strict constraint is what makes power saving possible. So the RF front-end digital signal processing chain only need to cover for the active bandwidth part. Now let us talk about initial downlink bandwidth part. The initial downlink bandwidth part is the first bandwidth part a UE uses when connecting to the network. If SIB1 includes initial downlink bandwidth part parameter, the UE uses that configuration to establish its initial receive bandwidth part. If it is absent, then the UE derives the initial downlink bandwidth part from the MIB using a corset for type 0 PDCCH. The key parameter for bandwidth part is location and bandwidth, which uses a compact encoding to specify both the starting CRB and the number of CRBs using parameters. The resource block stat value is derived from this, and this combined with offset to carrier gives the absolute position of the bandwidth part. If you are confused about what offset to carrier is, then I recommend watching the previous video, part 2 of the resource grid series, where I explain in detail what point A and offset to point A and offset to carrier is. The initial downlink bandwidth part always has bandwidth part ID equal to 0. So this is a fixed convention in the standard. Now let us talk about dynamic bandwidth part switching. Dynamic bandwidth part switching is where the concept of bandwidth part really shows its value. The network can change which bandwidth part a UE uses in real time simply by controlling the bandwidth part indicator field in the downlink DCI. So this happens on the PDCCH. The DCI is sent on PDCCH. When the UE has a large data to receive, say it's downloading a software update, then the network can switch it to a wide bandwidth part to maximize throughput. When the download finishes and the UE goes idle, then the network can switch it back to a narrow bandwidth part. So this helps in power saving. Or it can let the inactivity timer kicking and then switch the UE back to the initial bandwidth part automatically. The bandwidth part inactivity timer is configured by the network, and when it expires without the UE receiving any scheduling on the active bandwidth part, the UE silently switches back to the default bandwidth part. So this all happens automatically without disrupting any higher layer connections. So this is 5G's version of power management done correctly in the radio layer. Now let me walk you through a couple of UE configurations where different bandwidth part configuration is used. So let's say that the base station is using two 400 megahertz RF carriers through carrier aggregation. So UE1 is the simplest. This is the first row. So this UE1 uses one carrier and one bandwidth part, which is covering the entire 400 megahertz bandwidth. Now UE2 uses carrier aggregation with two component carriers and two bandwidth parts per carrier. So this enables interband carrier aggregation. Now UE3 also uses component carriers, but with a single bandwidth part per carrier, supporting both interband and intraband carrier aggregation. Now UE4 is even more complex. So this has up to 4 bandwidth parts configured per carrier, and this gives network maximum scheduling flexibility. Now UE5 illustrates a crucial point. So it does not use the full carrier bandwidth. Thus, the key insight from this figure is that the UE does not need to use the full bandwidth part that is possible. It can be allocated a smaller bandwidth part, perhaps because the UE doesn't have that much carrier RF capability, or because it only needs a narrow band service. Thus, this is the key to serving different device types with the same 5G carrier. Okay, now let us consolidate this part 3. So bandwidth parts are one of 5G's most important features of flexibility. A bandwidth part is a set of contiguous common resource blocks with the same numerology. It can be a subset of carrier bandwidth. Up to 4 downlink and 4 uplink bandwidth parts can be configured per carrier, but only one bandwidth part is active per direction. Initial bandwidth part always has an ID of 0. Dynamic switching via DCI lets the network increase or decrease the bandwidth part that is allocated to the UE based on the UE requirement. The inactivity timer helps to switch the UE back to default bandwidth part if there is no scheduling that is happening in the bandwidth part that is configured to the UE. In part 4, we consolidate the picture with physical resource blocks. How are the resource blocks actually numbered within a bandwidth part? We also look at virtual resource block, which provide a clear abstraction of frequency diversity. Thank you for watching and see you in the next video.